All right, this is Ubaid on behalf of V Electronics, and in this video, okay, we'll be solving word problems relevant to square roots. Okay, so when it comes to square roots, okay, this is an example of a square root. Okay, so the opposite of a square, let's say 2 square, okay, the opposite of 2 square would be the square root of 2. Okay, and this is your square root sign. Okay, so let's go ahead and solve some word problems relevant to square roots. Okay, now starting with the first one, which has to do with a step ladder. Okay, so the height in feet of an object dropped from a 20-foot step ladder is given by h at t. So this is your function, f at x equals negative 16t squared plus 20, where t represents the time in seconds after the object has been dropped. How long does it take the object to hit the ground after it has been dropped? Okay, round to the nearest tenth of a second. Okay, so what you're looking at over here is the height of an object. The height should be equal to 0. Okay, for the object to touch the ground or for the object to be on the ground. Okay, and we need to figure out time, which is given by this variable, which is represented by this variable, t. Okay, so we'll need to isolate t to figure out the time it takes the object to reach the ground. Okay, so let's go ahead and write this equation. H at t equals negative 16t squared plus 20. So h at t equals negative 16t squared plus 20. Okay, negative 16t squared plus 20, which means if your h at t is 0, this will be negative 16 t squared plus 20. Okay, which basically means that negative 16t squared equals negative 20. All right, and your t squared will be negative 20 over negative 16. All right, negative signs cancel. Okay, and you can reduce this fraction to 5 over 4. Okay, which basically means that your t, since this is a square, it goes on the other side of the equation, becomes a square root. This will be 5 over 4. So square root of 5 over 4, we can use our calculator to figure out the time. So 5 divided by 4. Okay, and so this will be 1.118, which can be rounded off to 1.12. All right, so t equals 1.12 seconds. So it takes 1.12 seconds for an object to reach the ground. Okay, so for example, if you are on top of a roof, okay, or if you're on top of a ladder, this is how long it will take you to reach the ground. Okay, this is if you're in a free fall mode. Okay, not to mention if you drop something from your ladder, let's say a hammer or a tool, because of which you do have injuries all around the world. Okay, if you do drop something, this is how long it will take for that object to reach the ground. All right, the heavier the object, the more damage it causes. All right, so next up, let's look at another word problem. Okay, again, this one has to do with a step ladder as well. All right, so 20-foot ladder. Okay, obviously the length helps, especially if you're carrying your step ladder in your vehicle. A 20-foot ladder leaning against a building, okay, reaches a height of 19 feet. How far is the base of the ladder from the wall? Okay, round to the nearest tenth of a foot. Okay, so we have a 20-foot ladder. So we know the length of this ladder. Suppose this is your ladder. The length of this ladder is 20 foot or 20 feet. All right, so this is your length. All right, now this ladder is leaning against the building. Okay, so you have a building. Let's say this is a building, and the ladder is leaning against the building. So we know that this length over here, this is 20 feet. We know that this is 20 feet. And we know that the distance, okay, from the wall, let's say this is your wall. Okay, this is your ladder. Okay, and L represents length, which is 20 feet. Okay, distance from the wall to the base of the ladder is B. Okay, and you also know that the height that the ladder reaches, let's say you need to reach something. Okay, let's say you're installing a surveillance camera. Okay, let's say you need to reach a certain height for you to install that system. Okay, so let's say this height is 19 feet. All right, so this is 19 feet over here, which is H. So H equals 19 feet, length is 20 feet. You need to figure out your base. Now we can see that this is a right angle triangle, which means that this is 90 degrees. Okay, and we also know that for right angle triangles, you can use your Pythagorean theorem to figure out the unknown side, okay, given two sides. So we know that side 1 or L is 20 feet, side 2 or H, the height, is 19 feet. So we need to figure out B, okay, which is the distance from the wall till the base of the ladder. Okay, so we know that A squared plus B squared equals C squared. All right, so this is a right angle triangle. Okay, let's say your X, let's make this X at the bottom, your Y, and your R. So X squared plus Y squared equals R squared. This is the shortest side usually. Okay, Y, which represents height in our case. Okay, this will be Y squared. So X squared plus Y squared. Okay, the square of the base plus the square of the height will give you, okay, the length, the square of the length. All right, so we know A squared plus B squared equals C squared. And what we're trying to figure out is B, okay, the base. So we know that B squared will be C squared minus A squared. Okay, basically means this will be R squared or the length square. Okay, take away A squared. A squared, this is your square of the height. Okay, whatever measurement you have for the height, square of that measurement will give you your B squared. So B equals 20 squared minus A squared, which has to do with your height, and your height is 19 feet. So 19 squared. We can use the calculator to figure this one out. So this is 20 squared, okay, which is 400, okay, minus 19 squared, okay, equals 39. Now the square root of 39 will be 6.24, okay, which basically means that your base or the distance between the wall and the ladder will be 6.24 feet. All right. So again, why is this important? Okay, for you to reach a certain height, you will need to know the length of the ladder. Okay, and how far away from the wall should you keep the ladder for you to reach that height? Okay, it also helps to know the base. We want to figure out the stability of that ladder. Okay, so the the longer the base, the bigger the value for the base, okay, the less stable the ladder. Okay, because the slope for the ladder, which is this angle over here, is going to go up. Okay, so the higher the value for the slope, the less stable the ladder, because the ladder is more stable when it's standing up straight, leaning against the wall. Okay, the more you keep it against the wall at an angle, okay, the bigger the measurement for that angle, okay, the less stable that ladder, which means the chances and the probability of you falling down or you dropping an object is much higher, okay, if the slope is big enough. All right, so apart from that, this is Ubaid on behalf of Electronics. Have yourself a great day.